The lesson topic for this video is exponential and log word problems. Just so you're aware, on a test, an assessment, our level 2 questions will give you the equation for the problem and you are going to be required to solve. The level 3 questions, on the other hand, you will need to write the equation and then solve it as well. Let's do a couple of examples. The examples I do with you include a part where we are going to write the equation. That'll be our first step. So we will write the equation, and then when we solve it, that would be like the level 2 part. Okay? I'll explain that more as we go. Okay, so our first example says the monthly cost of groceries for a family of 4 is $786 and is rising at a rate of 3.5% annually. So the first job, and this again makes it a level 3, is that we're going to be asked to write the equation for the cost of the groceries. I hope you recognize this as an exponential growth situation because it is rising, the cost is rising at a percentage rate, which makes this an exponential. So remember, please, very important that you remember that 3.5%, we're going to move that decimal 2 places to the left to write it as 0.035 when we write our equation. Remember that y equals a, the original amount, times 1 plus the rate raised to the x power is our exponential equation. We need to fill in the original amount, which is $786. And we're going to fill in the rate, which we know right here as 0.035. So 1 plus 0.035, and that's raised to the x power. All right, we probably should simplify this by adding our 1 and our 0.035, and if you did that in just one step, of course, that is fine as well. So there is our equation. So the second question, the second part of this would be like the level 2 type of question if the equation was already given to you. Again, it's a level 3 question if we first have to write the equation ourselves. Algebraically, find the number of years until the cost of groceries is $1,000. Again, that's based on if it continues to rise at that same 3.5% rate. Okay, so we're going to write y equals 786 times 1.035 raised to the x power. And we are going to fill in, okay, think about this for a minute. It says find the number of years. Okay, that is going to be solving for x. If we knew what x was and we put it in right here, that would be what we've done on previous units. But what we're doing now is that we're going to say we already know the future cost of the groceries, $1,000, and our job is to find out when that will occur. So we need to solve this exponential equation. And how do we do that? Well, here's the deal. We have our variable in the exponent, which means we have our base, 1.035, raised to an exponent. Remember that in order to solve for x here, we need to first isolate our base and exponent. Here's the base and the exponent. We need to isolate those. So we do that by first dividing by 786 on both sides. When we do that, we will end up with 1.035 raised to the x power on this side, and 1,000 divided by 786, which is 1.272 on this side. Notice now that we have an exponential equation that we can solve, and we solve that by using the inverse of the exponent, and that is a log. So we're going to go ahead, I'm going to use my space over here. I'm going to rewrite this as a log. Log base 1.035 of 1.272 equals x. All right, so now we can't compute this with our calculator because the base is not 10. It is not a common log, so we are going to use the change of base formula. So we need to do the log of 1.272 over the log of 1.035, and we're going to solve that with our calculators. And when we do that, we get x equals 6.993 So our answer is approximately 7 years from now, the average price for groceries for a family of 4 is $1,000 per month. We could write about 7 years. All right, let's do one more example here. Example 2. You put $1,150 in a bank account, earning 4.2% annual interest, compounded quarterly. Obviously, I really hope that you notice right here that it says compounded quarterly. We need to use our compound interest equation. So, write the equation for the amount of money in the account. Remember that our exponential growth looks like this, but our exponential growth with the specific example of compound interest is slightly different, and it's y equals a times 1 plus the rate divided by the number of times per year that it compounds, all raised to the number of times it compounds times the number of years. So we're not using this one in this example. We need to use our compound interest equation. So we're going to put the original amount in, which is $1,150. And then we have 1 plus the rate. Again, be careful with the rate. We need to move that decimal 1, 2 places to the left. So 0.042 divided by n, the number of times it compounds in a year, which is 4 times per year, right? Because quarterly means 4, and there's 4 quarters in a year. And then we need to raise that to the n, which is 4 times x. Now what I would recommend for this one is I would actually recommend that you simplify this as well, simplifying the 1 plus 0.042 over 4, so that when we write that down here and then we put a number in to solve, we can have a simpler situation. So I'm going to rewrite that right down here. So y equals 1,150. And on your calculator, you can add 1 plus 0.042 divided by 4, which is 1.011 when rounded to 3 decimal places accurately, and then raised to the 4x. So our second part here, algebraically, find the number of years until there is $1,300 in the account. Now I'm actually going to change this example slightly because $1,300 is not actually a very large amount of growth with a 4.2% interest rate. So I'm going to say, let's say we need $5,000. Okay, so let's put this as 5,000. All right, so in order to solve this, to find out how many years it takes to get $5,000, we're going to start by, of course, putting 5,000 in for y, which will be our new total amount in our account. All right, so I just rewrite that, putting 5,000 in for y, and now again we need to solve for x. Since x is in the exponent, we know we have a situation where we need to use a log. We have a base raised to a power. We need to isolate the base and power, so we need to get rid of this. I'm going to divide both sides by 1,150. And we get, on the right here, we keep the 1.011 raised to the 4x equals 4.348. All right, now our base and our exponent are isolated, and now we know we are going to rewrite this as a log so that we can solve it. So I'm going to go ahead and write log. The base is 1.011 of 4.348 equals the exponent, which is 4x. All right, I'm going to work this way this time. Sorry about that. Now at this point, because we have a base in our log that is not 10, we need to once again use the change of base formula. So we're going to write log of 4.348 over log of 1.011 equals, now be careful about this, equals 4x. Okay, this time it equals 4x. We need to keep that there. All right, and when we divide that out, we get 134.6 0.344 equals 4x. And then we divide both sides by 4 to get x completely alone. And now we know that x equals 33.586. So how long will it take to accumulate $5,000 if we put $1,150 in a bank with 4.2% annual interest? The answer is about 33.5 years. All right, that is it for now.